Hello guys, this is Paul McWhorter with TopTechBoy.com, and we're here today with episode number 107 in our incredible new tutorial series where you are unleashing the power of your Raspberry Pi Pico W. What I will need you to do is pour yourself a nice tall glass of ice cold coffee. That would be straight up black coffee poured over ice, no sugar, no sweeteners, none needed. And as you're pouring your coffee, as always, I want to give a shout out to our friends over at Sunfounder. Sunfounder is actually sponsoring this most excellent series of video lessons. And in this class, we will be using the Kepler kit for Raspberry Pi Pico W. Now, hopefully most of you guys already have your gear, but if you don't, take a look down in the description. There is a link over to Amazon, and you can hop on over there and pick your kit up. And believe me, your life and my life are going to be a whole lot easier if we are working on identical hardware. But enough of this shameless self-promotion. Let's jump in and talk about what I am going to teach you today. And what I'm going to do is I am going to give you my solution for the homework assignment that I gave in lesson number 106. But I must first ask, were you able to do it? If you were successful, leave a comment down below. I am legend. Double chest bump. And if you were not successful, leave a comment down below. I folded up like a cheap Walmart lawn chair. But hopefully most of you guys were able to do it. Those of you that have kind of been in this class for 106 lessons, you ought to be getting pretty good at it. But what was the homework assignment? The homework assignment was to increase the precision of your distance measurements on the old what is this thing? I can never remember what this thing is called. It is the HC-SR04 Ultrasonic sensor. Now, in last week's lesson, I showed you in MicroPython how to very simply make this thing operate. And then what I showed you was I showed you that there were problems in timing using MicroPython. So your homework assignment was to go in and get very accurate distance measurements by controlling the HC-SR04 ultrasonic sensor using the state machines instead of just doing it in MicroPython. And I can kind of demonstrate what the problem is here that we saw last week if I come in here. And let me show you first of all that this was what we were supposed to be trying to do. I got to get out of your way, okay? That what we needed to do was on the trigger pin, we needed to generate a very accurate 10 microsecond trigger pulse. And then after that, we needed to very accurately measure the echo pin time, how long the echo pin stayed up. And that would then tell us what the ping travel time was. And then from the ping travel time, we could go through this conversion and then we could calculate distance in centimeters. Now, if you want to understand that, go back and watch the lesson last week, but that's what we're trying to do. So what does that trigger pin need to be? It needs to be 10 microseconds. But if we come over here and practically look at our setup, let me go ahead and tell you how we have this thing hooked up. The leftmost pin is connected to 3.3 volts. The next pin is I believe the next pin, I got to look at that to make sure that I tell you that. I need to be looking at the picture when I tell you. And what it is now the second pin is the trigger pin. We have the trigger pin connected to GPIO pin 16. The third pin is the echo pin, and we have the echo pin connected to GPIO pin 17, and then the fourth pin over is the ground. And so if you want a better description, go back and watch last week's video, but that is what we are doing. Now, I'm sitting here running last week's program, and as I'm running last week's program, I am generating 10 microsecond pulses. I just say, go up, wait 10 microseconds, come down, I should get a 10 microsecond pulse. But when I look at the scope is set on 5 microseconds per division, and I've got 1, 2, 3, 4, 5, 6 divisions. So 6 times 5 is 30 microseconds. I wanted a 10 microsecond pulse. I got a 30 microsecond pulse. Why? You cannot trust MicroPython on timing. It can be off doing anything. And so if we need precise timing, what we need to be doing is, to get precise timing, what we need to be doing is we need to be using the state machine. So your job was to go in and on this sensor, redevelop the code to use these state machines. Okay, hopefully you guys were successful in doing that, but what we can do is we can jump in and I can start coding this thing up with the way that I did it. All right. So let's just jump in. This isn't a whole lot of code, but it's a whole lot of thinking that we've got to do to kind of think through this. So what do I want to do? I'm going to be using the state machine, so I need to import RP2. Okay, we're going to be using the pin, so from machine, I want to import pin, and then I need to import time because you never know when you might want to do a little delay here or there. All right, that looks good. Okay, that all looks good. Now, what I need to do is I need to give MicroPython a heads up that we've got incoming state machine code, and I do that with an @ and then rp2.asm_PIO. And now I need to set. I'm going to define these as set pins because really on that trigger pin, I just need to set it. There's nothing but just setting. So it's easier to do set than out, I think. So I will do set init, and that's going to be equal to rp2.pio.out. It is an output pin, and then it is going to be out, and we're going to initialize it low. So it will start out with the trigger pin being low. Now I'm going to define my pulse program, and that's going to be my state machine program. It's going to do two things. It's going to generate a 10 microsecond pulse on the trigger pin. Then it's going to look at the echo pin. It's going to wait for a 1. When it sees a 1, it's going to start counting as it waits for a 0. And then at 0, then it's going to take that count and it's going to return that count back to MicroPython. Okay, so that's what it's going to do. And let's go ahead and say we're going to need a wrap target like that. And then this is where the magic happens. And then what we're going to do is a wrap. Okay, and guys, I could jump in here and start coding, but when I'm thinking at the higher level of, I've just kind of, put the place for the machine code, but I like to come down and instantiate and set my pins up. I'm kind of thinking at that upper level. I like to do that, and then we can come back and dive in and do the code. So what am I going to need? I'm going to need a trigger pin, and that's going to be equal to, what did we say? The trigger pin is pin 16, and that's going to be a pin.out, like that. Okay. Now I'm going to need an echo pin, and that's going to be a pin what? Pin 17, and then that's going to be a pin.in. Remember last week I made it a pin.out. It's quite confusing. The echo pin, you're listening. It needs to be an input pin. Okay, while we're up at this high level, let's go ahead and instantiate our machine. So the state machine is going to be equal to rp2.stateMachine. And I'm going to use state machine 0 just because I can. And I'm going to call, what will this call? This will call pulse program, or it will use pulse program. And now we're going to be working at a frequency of 1 million hertz. 1 million hertz. 1, 2, 3, 1, 2, 3. Now you can do anything. It needs to be pretty fast, but if we're generating a 10 microsecond pulse, you wouldn't want to set this to operate at kilohertz, right? It needs to be operating at megahertz. And so then what would it be to generate that 10 microsecond pulse? It would be 10 clock cycles. And that would be, 1 million hertz in 10 cycles would give you 10 microseconds. All right, now we need to set our base pin, and our base pin is going to be what? Our base pin is going to be what we just said was the trigger pin. Set base trigger pin. Now also we've got to have an input pin, right? Which is going to be that echo pin. So I'm going to say in base is going to be equal to echo pin, right? Like that. So we got the set base and we've got the in base. Trigger pin and echo pin. I really like to try to look at this very carefully because if you have some subtle error in this, it can be very hard to debug later. Okay, so I'm just kind of looking over it. That looks pretty good. All right, so what else can we do here? Well, I'm going to go ahead and I'm going to write the rest of the program. I'm going to do the hard part last. So now what I'm going to do is I'm going to say while true, when is true, true is always true. And then what I'm going to do is I am going to SM my state machine. You know what else I should do here? Right here, there's something very important I should do, sm.active. You see, it's just easier to remember all this stuff while you're up here at this higher level. So I've activated the state machine. Now what I'm going to do in this loop, I'm going to put out to it, I'm going to put a number which will 32 bits of 1 because I want to absolutely set my registers to the highest number. And then as I go through that loop, looking at the echo pin, I will, every time through the loop, I will decrement because I can't increment. I wish that I could set the registers to 0 and then count up. But the only thing on that jump that I have is decrement X. I don't have an increment X. So what have I got to do? I've got to start at the maximum number. I have to count down. And then I have to take that remainder and invert it, and then that will be the count up number. And I think we did that in earlier things, so you guys should be pretty familiar with that. But I'm going to give a 0x, which means hexadecimal, and then I will need 8 numbers because each hexadecimal digit is 4 bits. I need 32 bits, so I need 8 hexadecimal numbers, and the largest hexadecimal is F, that's 15, so I'm going to put FF, 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 8 Fs, and that will max out a 32-bit number. And I'm going to check that 1, 2, 3, 4, 5, 6, 7, 8. So that's going to go eventually into a register back upstairs. Okay, now I'm just going to do a print, and I'm going to say pulse launched. That'll just help me see if the code is running. And then what I'm going to do is my clock cycles is going to be equal to sm.get. Okay. Now it's going to be times 3 divided by 2. That's the number of clock cycles. Why? Because like if I have 3 commands in my counting loop, that means that each loop will have 1, 2, 3 clock cycles. And so the number of counts should be 3 times the number of times I go through the loop. So I'm counting the number of times I go through the loop. I'm going to multiply by 3. Now I have the clock cycles, but that is for the ping to get from the sensor to the target and back. So then I need to divide by 2. Now with that, we can now just say distance. Distance is going to be equal to clock cycles times that magic number that we derived last week that I showed you over here. And if you want to understand it, go back and watch the lesson from last week, but that 0.0343. So we'll come back over here and we put in our magic 0.0343 like that. Okay, and now let's print distance to target, like that, okay? And then space, close, and then distance, like that. And then let's, do I need a delay in here? I'm kind of thinking that I should put a delay in here. So I'm going to put a time dot sleep of about 1/4 second, 0.25, like that. Okay, that should be good. So you see, now I've got the kind of high level stuff going. And now when I program this, when you see how the rest of the program works, you'll kind of see what we need to do here. So this is where we've got to be very careful in our thinking and in our coding. So what do I need to do? Well, I've sent this number that I want to put in the register. It's starting to rain outside. Okay. I don't know if you probably can't see the rain, but it's getting a nice little rain coming up. But I'll return to the code. So I want this to go in my register. Probably I'll try to get it to the X register so I can count. So what I want to do is I want to get that. I want to pull. Now I think pull will default to block, but I'm going to do a block pull just to make sure, because I want to stay here until I kind of get the go command. This put is sort of the go command for the state machine to go in and do its magic. So I don't want the state machine to run off and start doing stuff until the main program has sent that register and has told it it's time to go. Now that's going to end up in a pull. You're going to end up where you're going to end up in the OSR. So now I'm going to want to move to my X register what was in OSR. Why? I want that F to be my counter that I will count down from. So I'm going to move OSR to X. Now we are ready to go. So I'm now going to set pins. Which pin would that be? That's the set pin. Okay, I'm going to set the set pin, and I am going to set the set pin to 1. Okay, I'm going to set it to 1. Now, how long, that my friend is the trigger pulse. How long do I want that trigger pulse up? I want it up for 10 cycles. So I put a 10 here, but this is in addition to the command itself, so I put -1. Now, why didn't I just put 9? Because then if I look 9, okay, 9 plus 1 is 6. So what I do is to try to help me understand the timing, I always put 10 because it will be the 9 plus the 1, which gives me 10. And that way I can always count by just looking at that number. Maybe that sounds backwards to you, but it just makes it a little easier to me. Okay, so now I've got a 10 microseconds up. Okay, I got a 10 microseconds up. And so what do I want to do now? I do a set pins 0. Okay, so now that pin has gone 0. So as the program is setting up, it's setting at a 0. Why? Because I initialized it to 0. Then at the perfect time, it's going to go up. It's going to stay up for exactly 10 clock cycles. Each clock cycle at a megahertz is 1 microsecond. So now that pulse is up for 10 microseconds, and then it goes down. Now this is pretty easy counting here because I'm not having to loop or anything like that. I'm not having to loop for anything like that. And so that makes that pretty easy. So now what did I do? I gave my trigger pin a 10 microsecond pulse. Now all of our attention has to go to the echo pin. The echo pin. So what do I need to do? I need to sit and wait. I need to sit and wait. And I should probably show you this over here. Okay, so what did I just do? I just generated this pulse. So that is done. Now I need to sit and wait for what? The 1 on the echo pin. So what do I need to do? I need to wait for the 1. Okay, I need to wait for the 1. So let's come over here. So what am I going to wait for? I'm going to wait for a logic 1, and I'm going to be looking at what? The pin, which is the input pin, which is the echo pin. Okay, it is the echo pin that I'm going to be looking at, and that is pin 0. Now, what does pin 0 mean? That means it's relative to the N base. The N base pin 0 would be 17. The N base pin 1 would be 18. So you see it's all relative to that. Does that make sense? Okay, so this is getting scary. I've got to really be careful here. So I wait for a logic 1 on my input pin 0, which is pin 17. Now is where all the shucking and jiving has to happen to do the countdown. All right, so what do I need to do? I need to have a label of, I'm just going to call it land. Okay, so what is this land business? This is just my looping. Now notice that this is not going to take a clock cycle. This is just a label. It does not use a clock cycle. So that is where I'm going to land in my loop. All right. Now, what I want to do is, it's kind of like I've got to read that echo pin. It's like I got to read that echo pin. I got to put it somewhere I can do something with it, because I need to know, is echo pin high or is echo pin low? If I get here and it's high, I keep counting down. If it's low, I need to jump out. So I need to know what it is. So I'm going to move to my Y register from my pins. Okay. Which pins? That is the echo pin. Okay, that's the echo pin. It's really confusing how sometimes it wants you to write pins and sometimes it wants you to write pin. And so you kind of got to look that up every time to make sure that you're doing it right. So what am I going to do? I'm going to move the value of the echo pin to Y. Why? Because X is busy right now keeping track of my countdown. So what I'm going to do is I'm going to make a note here that that's going to take 1 clock cycle. Whether, you know, it moves the data, and then that is going to take 1 clock cycle. Now I want to jump if there is nothing in Y. And what do I want to do? I want to jump to move on. Okay, if I got here, the pin is 1, and therefore Y is 1. But when that echo pin comes down and I move it into Y, that means the game's over. The pulse has come down. What do I want to do? I don't want to keep counting. I want to move on. So I better put my target down here. Label. Move on. All right. And so that means that I'm going to stop counting down. But if there is something in Y, I won't jump. If there is something in Y, I won't jump to move on, but I want to jump. And this is where the magic happens. I'm going to decrement X, and I'm going to go back, and I'm going to try again, back to land. Like that. Okay, but what happens? It goes from F, 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 F to F, 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 E. It decrements it by 1. And if I quit here and inverted it, that would be the number 1. For what? 1 time through the loop. But 1 time through the loop is going to be what? This was 1 clock cycle, okay? And then this, whether you jump or not, is going to be 1 clock cycle. And then this jump is going to be 1 clock cycle. So 1 time through this countdown loop is going to use how many clock cycles? 3. And so that's why when I return it, SM get. That is the count, which I multiply by 3 because there's 3 clock cycles. Why do I do it here? It's a little hard to multiply in the state machine. Okay, so now I jump to X decrement, I jump to land. Okay, X decrement, I jump to land. Now, this one is where I'm going to jump to when I'm ready to move on. And then what do I need to do? Well, I need to move to the ISR. Why? Because Python gets from the ISR. So when Python goes out to get the data back, it's going to be looking in ISR. But where is my data right now? It's in X. But what is the problem with the data in X? It goes from F to E to D to C to B to A, right? to 9 to 8. So you see it's inverted. So I need to move to ISR, the invert of X. Okay, so what am I going to move to ISR? Instead of F, E, D, C, it'll be 1, 2, 3, 4, or it'll be 0, 1, 2, 3, 4. If you kind of think in hexadecimal. Okay, so move ISR and invert it to X and then wrap. Now, before we wrap, I've got it in ISR, but I got to bring it home by what? Pushing ISR to FIFO, and then that get down there will get it. Oh my goodness. Man, am I going to spend all day here trying to debug this thing? Am I going to spend all day here trying to debug this thing? This could be painful, but let's see if I can get this set up. And then I'm going to put this. I tried to be pretty careful, but then let's see if we can come over here. Okay, and I'm going to go ahead and see if I can get this thing. I think that should be set up to see the pulse. See, I like to look at the scope to even see, because I mean, man, no telling how many typos we have. And so I just need to see, am I even getting a pulse? Am I getting the pulse? Am I seeing the echo pin? Am I even seeing any action at all? Okay, so. And I guess, do I even have a good view? Maybe. Yeah, maybe that's kind of a view that I can show you there. So let's go ahead and run this thing and see what happens. Okay, pin is not defined in line 22. That looks like a pretty simple case problem. Did you guys see that? I was really trying to be careful along in here, but I guess I wasn't careful enough. Okay, let's run it. Okay, extra keyword argument given in 23. Okay, that I tried. Remember how I was saying I was being so careful? (23) State machine RP2 state machine 0 pulse program frequency. Okay, there was not an E there. All right, and you guys could see that. I know you're dangerously not able to quite see that, but I think you saw what mattered. Okay. Boom! Look at that. Look at that, guys. 10.67, and look at this. It almost ran the first time. Look at this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And at 10 centimeters, I am reading 9.95. Look at that. Okay, guys, let's look over here. Let's look. Let me come in where you can see this better. Now, did we generate a 10 microsecond pulse, I ask? Okay, now what I want you to see is I am set on 2 microseconds per division, and I have 1, 2, 3, 4, 5 divisions times 2 microseconds, exactly a 10 microsecond pulse. And I want you to look at this. Do you see how rock solid that is? And that thing is sitting there firing 4 times a second. And there is not even a hint of jitter in this. Why? Because it's being done on the state machine and not being done in the MicroPython. Okay, it's being done in the state machine and not being done in MicroPython. And so we are getting a rock solid pulse, okay, a rock solid pulse, trigger pulse. Now let's come in and let's cut this back and see if we can come in and let's see if we can look at our, yeah, we're going to see it. Okay, there is our echo pulse. And remember when we did it last week, how that thing was jumping around, and look at how rock solid that, echo pulse is. And again, that isn't sitting there frozen. That is continuing to run. And if we look over here, look at this. I am at 10 centimeters and I am reading rock solid. And right, this isn't frozen, right? That is scrolling up 9.95 centimeters. Okay, guys, maybe you think the old man gets excited over silly little things, but do you see there's some things I hope you see? I hope you see. One thing is how it's really, really neat to have the oscilloscope. And if there's any way you guys can manage it, I've got a link down in the description. You can order oscilloscope if you have the coin for it. If you do not have the coin for it, you can take every single lesson in this class and you can get every single amount of learning that you need without it. But if you can get it, it is a really nice extension to your toolkit. Okay, it's a really nice extension to your toolkit. Okay, guys, what we want to do for homework for next week is, what I want you to do for your homework for next week is, I want you to extend this where you add the SSD 1306 little LCD, the 1306 OLED, okay, the SSD 1306 OLED, add that to it, and then also add like a little go button and make a little unit that you can press a button to make a measurement. It'll make the measurement and then it will give you a nice display. It will give you a nice display of the distance. Okay, so I want you to take this to the next level where you're kind of getting sort of like a really cool little prototype going. Okay, guys, man, are you guys getting tired of the state machines? I hope not. But I hope that you're having as much fun taking this class as I am making it. As always, I want to give a shout out to you guys who are standing with me on Patreon. This type of lesson does not get millions of views on YouTube, and therefore the only way I can continue to make these in-depth lessons is to get support from my Patreon. So thank you guys. You can also help me by leaving a thumbs up on this video and also by leaving a comment down below. If you haven't already subscribed to the channel, when you do, make sure you ring that bell so you'll get notification when future lessons drop. And most importantly, share this video with other people, because the world needs more people doing engineering and fewer people sitting around watching silly cat videos. Paul McWhorter with TopTechBoy.com. I will talk to you guys later.